Welcome to this video on problem-solving skills in VCE General Mathematics Unit 2, focusing on bivariate data. Today, we'll explore how problem-solving differs from simply learning concepts or applying them. Let's first understand the three different types of mathematical thinking. First, we have learning concepts, which is about understanding definitions and theory. Second, we have application of concepts, which involves using formulas and procedures in routine ways. And third, we have problem-solving skills, which requires analyzing situations, making decisions, and applying knowledge in non-routine contexts. Let's explore each type in the context of bivariate data. Learning concepts involves understanding what bivariate data is, what correlation means, and how to interpret scatter plots. For example, knowing that a correlation coefficient ranges from -1 to +1, with +1 indicating a perfect positive correlation. Next, application of concepts involves using what you've learned to solve routine problems. For instance, given a table of data, you can calculate the correlation coefficient, plot the points on a scatter plot, and find the equation of the least squares regression line using standard formulas or your calculator. Now, let's focus on problem-solving skills. This is where you apply your knowledge to unfamiliar situations and make decisions beyond routine calculations. Let's work through an example. A researcher collects data on students' study hours and test scores. The data shows a positive correlation, but one student who studied 20 hours scored much lower than expected. Let's visualize this situation. Here's a scatter plot of the data, showing study hours on the x-axis and test scores on the y-axis. Notice this data point here. A student who studied 20 hours but only scored 60 on the test. This point doesn't follow the general trend and is what we call an outlier. Now, let's approach this problem with critical thinking. Here are some questions we need to answer. First, how would we identify this data point as an outlier? Second, what impact does this outlier have on our regression line and correlation coefficient? And third, what should the researcher consider before removing this data point from the analysis? These questions go beyond simply applying formulas. They require judgment and context. Let's answer the first question. We can identify the point as an outlier by looking at its vertical distance from the regression line. This vertical distance is called the residual. The outlier has a much larger residual than the other points. Statistically, we could use methods like measuring if it's more than 2 standard deviations from the predicted value. Now for question B. What impact does this outlier have on our regression line and correlation coefficient? The outlier pulls the regression line down, making it less steep. This means our model would underestimate the relationship between study hours and test scores. It also weakens our correlation coefficient, making it lower than it would be without the outlier. The value of R would decrease from about 0.98 to 0.72. For our final question, what should the researcher consider before removing this data point? This is where problem-solving skills really come into play. The researcher should consider, first, is the data point a valid observation or an error? Perhaps there was a recording mistake. Second, is there a reasonable explanation? Maybe the student was ill during the test despite studying hard. Third, what is the purpose of the analysis? If we're trying to understand the typical relationship, removing an unusual case might be justified. The key insight is that we need to make a reasoned decision, not just apply a formula. To summarize, let's distinguish between the three types of mathematical thinking we discussed. Learning concepts involves understanding what bivariate data, correlation, and regression mean. Applying concepts involves calculating correlation coefficients and regression lines using formulas. Problem-solving skills involve analyzing unusual situations, making reasoned judgments, and communicating your findings in context. In your VCE General Maths exam, expect to see questions that test all three of these skills with a significant emphasis on problem-solving. That's it for this video on problem-solving skills in bivariate data analysis. Remember, while it's important to understand concepts and know how to apply formulas, the ability to solve problems in context is what will really set you apart in VCE General Mathematics. Thank you for watching, and good luck with your studies.